Hello, my name is David Thibodeau. I'm the applications engineer for the consumer group and analog devices supporting the Sigma DSP products. So today we're going to use the ADAU1701 and the small eval board, and we're going to do a guitar distortion pedal. We're going to have some fun. And I'm going to zoom through some blocks I already kind of talked about in earlier videos. And there's a few blocks I'll just drop in and won't go into too much detail today because we're trying to keep these videos short. The goal of this video is to show how to use GPIO input and output and an AUX ADC pot for control and volume controls, and have some fun along the way. So what am I using for hardware? Okay, let me zoom back out here. Um, of course, I'm using the USB-I interface, the USB interface, USB-I we call it, and that's plugged into and powering the ADAU1701 Mini Z we call it. It's the small eval board. Have I have an audio connection coming in from another computer on a 3.5 millimeter jack stereo, and then output going to a little speaker sitting next to me here, and you'll be able to hear it a little bit. And then we're going to use this AUX ADC pot that's built into the board for volume control. Going to use this first GPIO switch to turn the pedal on and off, and then we'll have one of these LEDs that'll show that it's on or off. So I'll zoom in a little more so you guys can see what I was talking about. There's the GPIO switch, there's the LEDs, um, and let's get started. So going to the full screen here. Here I have SigmaStudio already up and loaded, and with no project, starting from scratch, as they say. So, oh, I got to go over to this screen. New project. And we're going to drag in the 1701 DSP. It loads up a bunch of stuff. We're going to go down to these communication channels. We're going to select the USB-I, USB interface, and then we make the connection. It'll come up as I2C, which is fine. That's what this board is designed to use. And so, why is it giving me a hard time? I'm not able to move this here. Okay, there we go. So, we're ready to start the schematic. Switch over to the schematic. You know what I'm going to do first, though? Because I always like to have these in this project. I'm going to go to the sources, DC cell, and then I'm going to go to readbacks, basic DSP, DSP function, and readback. And this is my test for communications that I like to use. Okay, so now let's start with the project. You do not have to have this in your project. It's only to test communication. So I can go link, compile, download now. We're going for design mode down on the right. It'll say active downloaded, and now I can hit read, and we're reading that. We're reading a 1, which means we're communicating with the part, and we got no error messages. Okay, so I/O input. We need to get input. That helps. There's the input cell. The first two are the ADCs. The rest are digital ins. We're going to need to put in the filters because every ADC, okay, filters miscellaneous, DC blocking. Every ADC has a little bit of DC offset, so we want to get rid of that. And I'm going to add an algorithm instead of copying this twice, so I have 2 inputs on each. So made double in one block. And a lot of ADCs have a built-in high-pass filter, and if they do, I recommend setting that register setting in the ADC. Then you don't need this. But in this case, we're using the built-in ones, and there is no register setting for a high-pass filter. So from here, I'm going to go. Should I go and get output really fast? Nah. I'm having fun with these videos, so we're gonna have some fun with this. Okay, let's go to let's get a compressor. I'm gonna go to RMS, standard resolution, lower range will be fine. Standard RMS compressor, because we want to kind of compress the audio coming in. And although it'd be better to hit it with a bit of gain. Nah, I'll leave it like this. There's so many different ways, signal flow wise, you can work this. We want to change this to mono because we have just a guitar, so there's no point getting more things. So we go to doing more processing than we need to. So go to Basic DSP, Arithmetic Operations, and in here this thing called a signal add. So this is just an adder, or summer adder, and so we're going to add the two channels. Using the adder here, since this is the same signal, it's coherent, we're going to add 6 dB, which is fine. I could use it here. In fact, I'm going to need a volume control as well. And I also want to add an oscillator because it's always good to have an oscillator to test things. So source, we had the DC, don't need that anymore. Oscillator, sine wave. So add a sine wave oscillator. We're going to add a volume control, adjustable gain. Actually, this one, we don't really need. Well, do we? Well, I'm going to set one. I'm going to grab one for the oscillator, so the oscillator can be at a lower level. So I'm just going to connect this, turn on the oscillator, turn this down to like minus 30-ish, upper 20s. But then for the main volume control, we're probably going to be adjusting this when we're using it. So let's make this a shared slider, clickless software slew. So we'll get one that has software slew on it so that it will slowly step and reach the desired volume level in a clean way and without any zipper noise and discontinuities. Okay, now we need to be able to switch between these two different inputs. So let's bring in a switch. Switches are disguised as muxes here, multiplexers. Well, I mean, that's what they are, multiplexers, but we're going to go with the one that just says switch. No slew is fine because we're not going to use this much during operation. It's only for testing with the oscillator. So we'll just do, and it's mono at this point already, so we'll do a mono switch. We'll connect the output to there, connect the ADC one to there, connect that there, and we're good to go. Well, let's just quickly get some output here so we can test things. I'm going to get a volume control because level detector, volume control. What am I saying? A level meter so we can see what's going on. Level detector with numeric display. We'll hook that up, and then we're going to send it to the output. So let's go to I/O, select output, grab the output cells. Now it's stereo coming out of this eval board, so I'm going to hold the control key down and do that. So I duplicate it. We're going to need to Y this, so I'm going to go up and use the T connection, because remember the T connection is free. It's all done in the compiler. It's not done in the DSP with anything that uses MIPS. And so at this point we could compile this and we'll have outputs. Let's compile. Link compile download. The bottom says active downloaded. I can hit go and see if we get something. Wow, gosh, not getting anything. Duh, that's because we're sending it to DAC 0 and 1. We need to send to DAC 2 and 3. Now, this is not directly a register setting, so this you have to, it went back to design mode. You have to link compile download to change those settings. And now I should be going good here. Okay, is it active? Yep, hit play. Ah, I'm hearing things. And we can see it on the meter. See, a minute ago we saw it on the meter, but we weren't hearing it. And so that's why I knew right away where to go for. Alrighty, so now let's start making the distortion box. Well, to make a distortion box, we need to add distortion. So I'm saying this as I'm moving this out of the way. I'll pull the meter up over here somewhere. So to add distortion, how do we add distortion? Well, in the library, you're going to see, let me dump this down here. you're going to see something called nonlinear processors. And that's where we get a thing called clippers. Hard clip and soft clip. Hard clip is, I mean, it's pretty much as you said, it's a really hard clip. It just clips it to a certain level. That's it. Um, Once it reaches a certain level, it just keeps it at that. Well, a standard cubic is a little more involved, and it will not clip as harshly and add other harmonics, which is better and more musical. So I'm going to do the standard cubic, and I'm going to put this in, and we should have distortion now. It's going to be a little hard for you to hear, but okay, I'm going to hit shift play so it does a loop. I'm going to try to sit a little closer to the speaker here. Well, I'm not hearing any distortion. First of all, I'm going to change this to go up to plus 24 so I can get some gain with the meter. Well, it's still sounding pretty clean. By the way, my sound file that I recorded was recorded pretty low in level. Well, I think that this speaker is distorting on that one. So it's clearly not distorting. Well, that's because this clipper is set to 1, which means a 1.0 full scale. And we're obviously not going to get above full scale coming in. So we need to set this to a lower level where clipping is going to happen. And 0.1 is a really good low level. I believe that's 20 dB down. Yeah, now we're hearing distortion. Alrighty, so we're hearing distortion. Now, we want to be able to, let's go to the volume control first. We want to be able to do a volume control. So let's put this in. Now I can obviously drop in another slider, but we want this to be external with a pot, like you would have on a guitar pedal. So you don't have to be using SigmaStudio on the stage. Anyways, that's a funny thought there. Let's go to volume controls. Volume controls, adjustable gain. Yeah, well, there's one of them that's going to say external control. External control, clickless software slew, only one kind. So let's do the external control. Now, when it says external, it doesn't necessarily mean external to the DSP, just external to the block. So we could control this with something else inside if we wanted to react to frequencies or whatever. But in this case, we do want to go outside of the DSP. So let's hook up the audio path. These green and blue squares there, connections for the audio. And we have that one input, which is external volume control input. That's the control input to it. It takes a number from 0 to 1 in a 5.23 number. Which is inside the 28 bits inside this DSP. It's a 5.23, and so it'll go from 0 to 1 in that format. And so let's get the GPIO AUX ADC inputs. So if we go to IOs and inputs, since this is an input, oops, scratch that, GPIO, and then go to input. You're going to see AUX ADC input as a block we can pull in. So let's pull this in, and I'm going to put in another readback. I'm just going to copy and paste here rather than drag another one in, because I want to be able to show you what the data looks like. You obviously do not need this readback cell to make this work. Now on this eval board, if you look down in the picture here, this eval board has one pot, and the pot is hooked up to the AUX ADC 3. There are 4 of them. There are 4 pots, but this is on the 4th one. It goes 0, 1, 2, 3. It's these programmers that start from 0, you know, those type of people. Anyways, so we're going to select aux ADC 3. So 0, 1, 2, 3. Yeah, I was gonna I was gonna tell a programmer joke, but I'll avoid doing that. Anyways, now if I go and let's link compile download, and we're gonna see this is not gonna work. Let me do the shift play again. Okay, it's like not working at all. I'm turning all the way up. I'm not hearing anything. I got volume control. And see, this is good to build up a project, by the way, a little at a time, because I know that these outputs are set correctly because we just were playing music through it. And all we added was this, and I'm not hearing anything. Well, this is because it's not enabled. So let's go over to the register settings. Hey, I'm going to turn this up because it's gonna come on. Go to Hardware Configuration tab, and then go to the sub-tab for the register controls, and verify that the control ADCs are enabled, and they are. Now it's up to the aux ADCs show up on the multifunction pins, and these all default as input, GPIO input, and not the ADCs. Well, MP8 happens to be where the aux ADC3 resides on that multiplexer inside the part. So we're going to select aux ADC3, and since it's a register change, we don't need to compile, and here it goes. Haha, we hear it. So, yeah, if we would have been watching the capture, we would have seen the write to the register. So now I should be able to adjust it. Okay, I'll wait for it to play again. There we go. It's hard for you to see, I know. It's working. Now let's look at the numbers on SigmaStudio. I'm going to do changes to... No. Yeah, I'd rather have it as hex. And we see it doesn't quite go to 0, but it's because there's some hysteresis involved. There is sort of noise control hysteresis selected, which is good to keep on there. And the most it goes up to is 7F. It doesn't quite reach a 1. If I go back to 5.19, you're going to see it goes up to 0.995. It doesn't quite reach 1, which is handy that it doesn't quite reach 1, because we can use this knowing it'll never reach 1. And so we can do some multiplications with this stuff later on, other tricks you can use with aux ADCs for like doing multiple positions, like switch positions and that sort of thing. So anyways, we're rocking on this. I'm going to turn off this continuous read because we don't need that going on. Now, pause that. What are we going to do next is the distortion. It's always on. I'd like to be able to have like a guitar pedal where you can press a button and it shuts off, and press a button and it comes on. So let's do that. Let's grab a GPIO in. I'm doing this again here. GPIO input, but this time we're taking a general purpose. We won't take an aux ADC. We'll take an actual GPIO. And this first button on the eval board, make that back onto the camera here. That first button is GPIO 9. So we're going to select GPIO 9. It's written on the eval board, by the way, in silkscreen. You might need a magnifying glass to see it, but it's on there, especially if you're of more advanced age. Now, how this works, I could show you with read back, but you can believe me on this. When you press, it's a momentary button. So if I press the button down, it'll go to 0, and let go, it comes up to high. Okay, great. But it doesn't hold a position. I have to sit there and hold it. And that's not how you want a guitar pedal to work. You want to be able to press the button and then keep playing, and then press it and keep, etc. So to do that, we need to use a toggle function. So we happen to have a bunch of GPIO conditioning cells. GPIO conditioning, which is designed for these uses. Push button. And you see one of the choices is toggle on and off. There's toggle on, toggle. So I'm going to hook this up to there. And then, we got to go to a switch. Okay. Now we need to put another switch in. Now we have a switch here that we can press these radio buttons, but that's not any good. We want it to be externally controlled from the GPIO. So let's go back to these muxes. In the let me collapse this down so it ends up being easier to see. And earlier we chose this regular switch, but in this case we want to do an index, what's called, I'll close that up, an index selectable. So it's selectable from a pin like we did with the volume control. And they have no slew or slew. We certainly want the slew. Mono is our choice. The reason why we want the slew is because we want to slowly crossfade between the two inputs when we switch it, so it's a smooth transition in and out. It'll sound better. A few little things, other things to mention as I hook this up here. Oh, well, alrighty. Now, this is the purpose of this is to bypass something. Oh, there is other thing I need to put in here. I just realized it looked too simple. It's a good idea when you're using a clipper to put a filter in, because it can create harmonics that are harsh, first of all, and some of them can cause trouble with the DAC. A little bit too high a frequency created in the DSP that could cause troubles with the DAC. So I'm going to quickly add a filter in here, then we'll get back to the other discussion. Okay, filters. We want a second order filter. I guess I'll use a double precision. We only need one channel. So this first one here, general second order. We're going to pull that in. Okay. We'll hook this up. Output of the clipper. And it's set up as a parametric peaking right now, but we need to change that. So click on that blue box and pull it down, and we'll select general, high pass, low pass, band stop, and defaults to low pass filter, which is fine. I don't want 1 kilohertz. I want about 10 kilohertz as a corner frequency for the low pass. It's a guitar. I mean, you can actually probably better be about 14 or 15K, but this is good enough for me at the moment. Leave the gain as it is in the Q, so I'll close that off. And so now you see that little picture change to a low pass filter, so it kind of gives you a clue. These other two buttons are pretty straightforward. Enable it on and off, so that's like a bypass for the filter, and then in phase or out of phase. Unfortunately, they use the phase word. They really should use the polarity word. But anyways, you get the idea of what its purpose is. So now we want to create a bypass. So we want to go between a distorted and not distorted. So we're going to grab it from here, and we need one of these nice handy T connections again over here, and we'll sorry, accidentally. So when the thing is flipping, it and you click, it will drop another object in there. I do that far too often. So we reconnect it there and take the T and connect it there. Let me get this cell up out of the way so it's not hitting. And there, we got our bypass. So now the control, I'm just going to wire this to it and make it look a little better there. There we go. I'm going to leave this up here for a reason. Right, now, there's a couple things to discuss. The number format of the GPIO goes from 0 to 1 of a 1.23 number. So the slew control doesn't use the whole number portion, because there's only 4 bits for the whole number portion, not counting the sign of an unsigned integer in the 28-bit DSP. So with only 4 bits, we can only go to 15. And so that would limit it. You could grow these mux to be a whole bunch of different inputs if you wanted to. So what we have done is we use an unsigned integer, but we use the LSB. 0, 1, 2, 3. That way we can go to thousands and thousands, more than the DSP could hold. But it doesn't limit us to 15. So we need to translate that GPIO 0 to 1 in 1.23 to be 0 to 1 in 28.0 or unsigned integer, so just to the LSB. Fortunately, this toggle block also does that for you. It's going to look at the input and it'll toggle it on and off as the inputs come in. But the bit that it toggles, you can choose. If you pull this down, you can choose any of the 28 bits, except for the sign bit. um, and so, and they give us a couple of, instead of bit 0, it says 28.0. You can do 5.23. You can do it the same as coming in a GPIO or any other bit. But in this case, the default setting is 28.0, which is the LSB, and it's just perfect. It's exactly what we want. These, warning, these muxes, many of them do not have limit protection because that takes a lot of MIPS to do limit protection in a DSP. It's not like a regular general purpose computer processor core. So, and all that this is an index. So the cell is going to say, I'm going to grab my input value from this memory position plus the offset that's coming in on this orange pin. And if it's 0, then it's that position plus 0, and so I'm taking my data from there. If this pin is a 1, now it's going to take the position from the next memory location up, which would be this other input pin, and etc. down the row. Well, if you give it a number that's more than the number of pins you have, it's going to just take that offset and go looking for the data, whatever happens to be in that memory location. So it's very unpredictable what kind of output you're going to get, if any. It might be just a big DC value. You just don't know. So you have to limit the input. In this case, I know this cell is only going to be 0 and 1. I don't have to do anything fancier than that. But you just have to be aware of this depending on what you're doing. Okay, so now GPIO 9 should be the deal. So I'm going to go link compile download. Oh, and it's telling me I have something disconnected. Unconnected pins. Oh, yes. It's reminding me something I forgot to talk about. These two diamond, little light green diamond pins are with the interface in and out. This is intended to be able to, this processor can store away up to 8 locations for various data, things like volume controls and that sort of thing. But it's to use this, there's some hardware things that have to be done and some software things. It's a bit complicated, but it's in there. So we have to hook up these cells. So if we go back over to the I/O and go to GPIO input, we see an interface read, and then go to the output and we see an interface write. So we need to hook these up. That interface write, all right, read to read, and this is a bit messy here, but for the moment I'm going to leave it there. And yeah, and now it's going to compile. Link compile download. Alrighty, hit my music. Hit it, James. Okay, now. Okay, here we go. Nothing. That's clean. That's distortion. Clean. Clean. Distortion. Yeah. Okay. So, I'll turn the volume down. So that works. It's switching the switch. It's holding the toggle. I just have to press it and let go. Now I'd like to have one of these LEDs show me when it's on or off. So let's go ahead and do that. To do this, we need a GPIO output, general purpose output. I happen to have that, already open. I/O, GPIO, then output, general purpose output. So we general purpose output, and we may as well just take it right off of this switch. The GPIO, by the way, since it's a hardware low and high, all it takes for input, it'll be low if it's 0. It'll be high when it's non-zero. So the number format going in really is inconsequential. 0 or just non-zero. Makes it nice and easy. Alrighty, so we're going to need a T. Another one of these nice T connections. It moved up on me. It's okay. I'm going to move this to the output, move that to there, hook up the GPIO, and those LEDs, it's on GPIO 10, and I could go here and say, oh, it doesn't work. Well, that's because we have to go over to the registers and look at because the GPIOs default as inputs, which is why we didn't have to go there when I selected the GPIO in on 9. It was already set as an input. But 10 is set as an input, and we want it as an output. So there's two choices, output or open collector. I think in this case, I'm just going to select output and go back to the schematic, link, compile, download, and then we'll hit the music. And we probably see, I'm going to zoom in even further, that we have an LED on. I'm going to try to keep out of the way here. See, it's off. But listen here. It's distorted and the light is off. Now it's clean and the light is on. I think I want it to go the other way around. Now we can put in a cell here to do a logic inversion, which takes up a few MIPS. However, though, we don't have to. We can go over to the hardware. This hardware is a cool little feature. On a GPIO, you can invert it. In hardware, free, no MIPS. So I'm going to do the inversion, and let's see if that actually worked. I hear distortion. That's clean. Rid of the distortion. And the light is on. Now it's backwards, see? It's perfect. Yeah! Now we're ready for our rock and roll album. We're going to go make a hit. Am I done with this? I think so. Yeah. We've done everything I kind of wanted to do. So save it away and have fun. There's a lot more you can do with this thing. Oh, did I ever set the compressor? I never did set the compressor. Oh, gosh. How could I forget that? You know, you can pull this down here, set the compression ratio to something a little more reasonable, put a little bit of a noise gate in there, and make a little softer knee point, add a little more gain in the input. It's always handy. Yeah, I want a faster attack, a little more hold. What do I want the hold to be around? Yeah, around 150-ish. And then a really long release time. These things are nice because this particular newer compressor has meters, which is really handy. So I'll hit shift play again. And it has the dancing ball to show you where you are. And we're not really hitting much compression here. There we are a little bit. Okay, so we're good. We'll talk more about these compressors in another video. But it's you can see it's a nice little compressor. So I think we're finally ready to say we're done. Thank you for listening, and tune in for the next one. Okay, that's it. Have a good day.